Welcome to Pure Mathematics 1, Chapter 4, Function, topic Composite Function. And now, in order to understand what is composite function, we will go through a logic change. So first of all, I have a function like f, x moved to x squared, let's say. So my input will be x, and so this function f, I will have my output, which is fx. My output, which is fx, so in this case my fx equal to x squared. Okay, and then I yield this x squared to be the input of the next function. So it goes through a function g, which is x plus x go to x plus 1. So here I have the input of this one will be x squared, and then after go through the function g's, I have the output, which is g fx. So this one, when the input is x squared, so the output of this one will be x squared plus 1. So this one, the composite function, can be also called the function of a function. You can see this one fx is a function, and now g's of fx will be the function of a function. We don't have to write in this form. We can say that g's f and x. We don't need to include the square bracket here. This one will be preferred to use, so don't need to care about the square bracket in here. Just use the g's fx. So is there any difference between g's fx and fgx? So let me rewrite the fx equal to x squared and g's x equal to x plus 1. And for g fx, we know that first we apply the rule for the fx first. So we have g's of x squared, which is the input, equal to, here we have x here, so we have x squared plus 1. And now we find the f g's x. So we have gx equal to x plus 1. So we have f of x plus 1 equal to x plus 1 squared. So these two, they are different. So please remember that the order of this one is really important. So you have to write them in order. If not, you will make lots of mistakes from getting the wrong orders. Let me try another example. Let's say fx equal to 3x plus 1 and g's x equal to square root of x plus 9. And if I apply the rule for f of g's x, so I have the f of square root x plus 9 equal to 3 multiplied by square root of x plus 9 plus 1. And if I use g's of fx, would be g's would equal to g of 3x plus 1. So it is equal to square root of 3x plus 1 plus 9, which is equal to square root of 3x plus 10. Now we will use this diagram to understand more about composite function and some condition for composite function. First, you need to know that this one gfx is called the g of f of x, and fgx is called f of g of x. This is how we can read this thing. So to start with, you can say that domain of f we contain all the possible input for the function f, and then it goes through the function f and it creates a range of function f, and then the range of function f must be contained within the domain of function g in order to make the composite function of g of f of x, which is this one, g of x, and to produce the range of g of f. So why the range of f must be contained within the domain of g? So let's take an example. Here's I have fx equal to the square root of x, and I have my conditions x greater than 0. I have my gx equal to 2x, and x can be any real number, and then we know that when fx equal to square root of x, so the range of f would be number which is greater than 0. Range of f will be greater than 0 because square root of a number which is greater than 0 will be greater than 0. And then we have the domain of this one, which is x. Here, domain of gx is any number which is real number. Okay, and you can see that the range of f, which is greater than 0, will be contained within any real number, because any real number is had two parts. One part is smaller than 0, and one part is greater than 0. And here, this one is contained within this one. So we can be able to find the composite function g of f of x will be g of f of x equal to 2 multiplied by square root of x. Okay, but now if we want to find the function f of g of x, can we be able to do so? The answer is no, because if we change in this direction, so we change the one up here, so here the range, because g, we use the function g first, so it's one here. This one will be changed into g. Here's g, here's g, and here's f, and here's f here, and here's our f of g of x. Okay, and look at this one. You can see that the domain of g will be x is equal to any real number. So the range of g will be the range of gx. Can be any real number, because its domain is here. When a real number multiplied by 2, it will be a real number too. And the domain of f will be greater than 0. Domain of this one greater than 0. And here you can see that this one is not contained within this one, because this one, any real number, contains two parts. One part is negative and one part is positive. The positive one is suitable, but the negative one is not suitable. We have the range of gx is any real number. Let's take -2. This one, -2, and then we put it in here, which is x greater than 0. It will not be suitable, so we cannot find the function of f g's x, because the range of g is not contained within the domain of f. This one failed, so we don't have the function of f of g of x. So please remember that when you use the composite function here, if you have a and b x, the one that we apply in this direction, we apply from the right to the left. First we apply the b first, and then we apply the a later on. So the range of the one applied first of bx, which is the one apply first must be contained by the domain I will write up here, domain of AX, the one which is apply layer. Remember that the range of the one apply first, which is this one, the one in here, must be contained by the domain of the one which is apply layers, which is the one we stand in front, this one.